Our new and final unit in Prob Stat this year is probability. And this first lesson, we'll go over some material that you've probably seen before in other classes, and some that you haven't, because we're just going to be going into an intro into what probability is, talking about some of the terminology, and doing some quick example scenarios. So, what's some vocab we want to be familiar with? These are a few words that are going to come up all the time in this unit. The first one, the big one, probability, which really simply we can just define as the chances of something happening. So if the probability is really high, then something is really likely. If probability is really low, then something is really unlikely. Other terminology in this first lesson here, outcome. Essentially, when you are doing a probability experiment, right? Something where there are multiple outcomes and it's random which one happens, then the result of one trial, the result of one coin flip, or the result of drawing one card from a deck of cards, that is known as an outcome. Connected to that is the sample space. The sample space is all of the possible outcomes. So if you flip a coin, the sample space is you get heads or you get tails. There's your sample space. Which I kind of jumped ahead a little bit because we're going to look at some sample spaces right here. So I just talked about this one. When I flip a coin, my sample space is either heads or tails. That's it. Those are the only two options. When I roll a six-sided die, my sample space, the set of all possible outcomes, is, well, I can get a 1, a 2, a 3, a 4, a 5, or a 6. Those are all of my possible outcomes. Flipping two coins, the sample space starts to get a tiny bit more complicated. So, again, we're saying, hey, I flip a coin, what are my possible outcomes? I can get heads, and then heads again. That is one possible outcome when I flip two coins. Or I can get heads on the first coin and tails on the second coin. Or I can flip it around. I can get tails on the first coin and heads on the second coin. And the last option is that I get tails on both coins. So we see here, when you flip two coins, the sample space actually has 4 possibilities. Now, rolling two six-sided dice is going to have a lot of possibilities. So we're not going to try to list them all out here, but it's pretty easy to visualize the sample space for rolling two six-sided dice. It looks like this. Now, you're going to notice one thing here when you look at this setup. When you roll two six-sided dice, it gives you this grid, which is 6 by 6. In other words, there are 36 total possibilities. Total possibilities. Hopefully I spelled that right. So that is one way you can kind of predict sometimes how many outcomes there are in a sample space. Is, for example, there were 4 for flipping a coin, because that was 2 options times 2 options. For rolling 2 dice, there's 36 because it's 6 times 6. There are a couple things I want to point out in the sample space. First of all, there are a few diagonals on here that are super useful for us. One of them is, let's say you are trying to get a doubles, like you're matching the dice. That makes one diagonal right here. 1, 1, 2, 2, 3, 3, and so on. Or the other diagonals that I want to point out here are the sums, where you add up the 2 dice. So, first of all, we have this diagonal right here. This adds up to 3. This diagonal here, all of these add up to 4. All of these add up to 5. So you can kind of see where this is going. All of these on this diagonal add up to 6. And we can go across the entire thing. So if you're looking at sums, the diagonals tell you what the sums are. So we'll use this sample space a lot when we look at some probability problems in this unit. It's one that I will provide a handout for so you have quick access to it. And it's just something you want to get comfortable looking at. Another sample space that not everyone is super familiar with, but that we will talk about a lot because it makes for a lot of really good probability problems, is a deck of cards. So in a deck of cards, a couple things I want to point out. There are, if we go across a row, 13 denominations. So like ace, 2, 3, 4, those are all denominations. There are also, if we go up and down, 4 suits. So that is clubs, spades, hearts, and diamonds. Those are your 4 suits. Another common term you might hear is the face cards. So all of these over here, Jack, Queen, King, the ones that have people on them, they are called face cards. So that's just another term you want to be familiar hearing. And we'll talk a lot about this sample space as we go on through this unit. But this will also be provided to you. You don't have to memorize the deck of cards. Now, sample spaces are not always as easy as, hey, flip a coin, or as kind of predetermined as, hey, here's the deck of cards, these are all the possible outcomes. Sometimes we have to figure out what the sample space includes. So let's look at the example of if you have 3 children, what is kind of the order you can have those kids in, and what are all of the possible outcomes? So if we look at, first of all, just the first kid, we're going to set up something called a tree diagram here. For that first child, you can have a boy or a girl. Now, if you had a boy the first time, we have more branches, because again, you can have a boy or a girl. And if you've had 2 boys so far, you can again have a boy or a girl. Well, you might kind of see where this is going because we can keep just filling in these branches. So let's say you had a boy the first time and then a girl the second time. You could have a boy or a girl the third time. And we can do all the same things on the other side. If you had a girl the first time, you could have a boy or a girl, and then so on. Boy or girl, boy or girl. And there is your first kid, second kid, third kid, right there, the rows. So when we're looking at our sample space, this can be a little bit weird to look at. Let's try to kind of read what this is saying. To read a possible outcome, I want to go down a branch of a tree. So for example, I could go, okay, boy, boy, boy. That is one possible outcome, is boy, boy, boy. Another possible outcome is boy, boy, girl. Right? If instead of going all the way down the left side, I were to cut over this way. So boy, boy, girl is another possible outcome. And you can kind of see where this is going. We can keep going down these branches. The next one over is boy, girl, boy. And then boy, girl, girl. And then girl, boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. So these are, let's see, 1, 2, 3, 4, 5, 6, 7, 8 different possibilities. Now, if all you want to know is how many possibilities are there, all you have to do is look at that bottom row. This will tell you, if you just look at this bottom row, that there is 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So you don't necessarily have to list them all to know how many outcomes there are. You can just look at the final bottom of your tree diagram. So there's our sample space for 3 different children, and if we're just looking at, did you have a boy or a girl each time? 8 possible outcomes. Now, so far we haven't really talked about probability, which is what we are focusing in on in this unit. When we're talking about probability, we like to talk about the probability of an event. So an event is just a set of outcomes of a probability experiment. And specifically, we are going to deal with two different kinds of events. Simple events, which is when there's only one outcome you're interested in, or compound events, which is when there are multiple outcomes that you are interested in having occur. And this, if you only remember one thing for probability, it should be this formula right here, this idea. To find the probability of some event E, all you have to do is look at how many different ways can E happen. So what is the number of outcomes in E, the event E, divided by what is the total number of possibilities in the sample space. This will give you the probability of an event occurring, this fraction right here. So same thing here, right? Probability. The probability we're going to focus on in this lesson is called theoretical probability, which means we aren't like flipping a coin a bunch of times to figure out what the chances are of something happening. We are just doing math to figure out what are the chances of something happening. And there are some rules when it comes to theoretical probability. First, all probabilities must be between 0 and 1, or 0 and 100% is another way to think about it. If the probability is 0, then it means that that event is impossible. It will never happen. If a probability is 1, then it means that event is guaranteed to happen. It'll happen every time. The sum of all of your probabilities in a sample space must equal up to 1, or 100%. Now this last one sounds kind of funny, but all it's saying is that if I, for example, flip a coin, heads has 50%, tails has a 50% chance, add those together, you get 100%, because something has to happen. I must get heads or I must get tails. It can't be nothing happens, one of them must happen. Now, the next thing we're going to do is we're going to check out a few problems. I'm going to break this up into two different videos here, so I'm going to stop our quick intro now and come back in the second video to do a few problems.